Hello again, everybody. Part E is polyurethane foam. This is the kind of foam you see in the spray can that expands and fills crevices around the house. The chemistry behind making a polyurethane foams is an addition polymer. Now, a condensation reaction happens between two different molecules, an alcohol and an isocyanate. And illustrated here is the formation of a single molecule of the resulting urethane. But you're going to see that the urethane molecules we make have lots of different hydroxyl groups on the alcohol, so that you do end up with a net addition polymerization. Now, if you made your polyurethane and it's supposed to foam up, right? But if it didn't have any gas in there at all, then it would just end up being a puddle of polymer, which is not very useful. So where does the gas come from? Well, the gas comes from the reaction illustrated at the top of this page, because in the presence of a little bit of water, some of the urethane, some of the isocyanate will form an unstable intermediate that can release CO2 gas. Now, not all of this happens. You still have a lot of the polymer in place, but some of the resulting groups will react with water to release an amine and carbon dioxide. It's this carbon dioxide that allows the material to foam. Now, when I illustrate the making of polyurethane, what we're going to see is this. We're going to take a substance illustrated here. It's a polyfunctional isocyanate, and we're going to react it with a polyol, or a molecule containing different hydroxyl groups. What can happen then is, as you add a hydroxyl group in a condensation sense to an isocyanate, because there are lots of other alcohols present, OH groups, these can then interact with other molecules of similar size, and you can actually get lots of three-dimensional cross-linking between the polymers. Again, there'll be a little bit of water present, so some of these will be unstable, releasing CO2, and you'll see the polyurethane begin to foam up. All right, I'm going to pause the video now, and we'll come back and we'll demonstrate how we make the polyurethane. All right, I've gotten set up for making the polyurethane foam, including will be a clear cup, a wooden spatula or stirrer, and then a little bit of food coloring to make it a little brighter. Now, the actual reagents I'll use are commercially available. One is a bottle containing a thick liquid that has the polyalcohol in it, or polyol. The other one has the isocyanate containing molecule. All right, so what I'm going to do is I'm going to put the alcohol in this cup first, and I'll put about equal amounts. So I put it into these little squeeze of things. It's a little gooey, so I have gloves on. You can hopefully see I'm wearing gloves. It's not very pleasant to touch. Matter of fact, I'll take these gloves off and I'll throw them immediately away following the demonstration. Okay, I've gotten about all that part A solution, the alcohol, in. Let me add a little bit of my couple drops of my purple food coloring. 1, 2, that should be, now I'll do a third one. Why not? Let's make it really bright. Okay, now I've got the alcohol in there, the alcohol containing, OH containing molecules. I've got my food coloring in there. Last thing is I'll add about an equal volume of the isocyanate molecule to the cup. I put in 2 droppers so I could get it in here carefully. Okay. And then I'll stir it very well, mix everything together. And then we're going to sit back. We're going to pause the video and we'll come back. And after a while, hopefully it'll start to foam up and you'll see what we know as polyurethane foam. All right. So there, I've given it a good stir. All right. I'm going to pause the video. I'll come back and we'll see what we see. Okay, about 5 to 6 minutes went by, and I have the sample off to the side. I'm going to reveal it to you. Here we go. Wow, look at that. Remember, it was just a puddle of liquid at the bottom of this cup, and over 5 or 6 minutes, it's foamed up nicely. It's only purple because I added the purple color, food coloring. I'm feeling the sides. The sides are still slightly warm. It's an exothermic reaction. Heat is being given off in the reaction. It's not too warm now, but it's still a little warm. Okay. As this gets a little bit longer time, it'll solidify hard, and I could actually take it out of this cup. Right now, it's still growing a little bit. I won't do that, but you can see clearly it has expanded beyond the little puddle at the bottom. That's because of all the CO2 being given off as a small amount of the urethane reacts with water to fall apart into CO2 and the amine. But it's quite dramatic, isn't it? Looks delicious. I wouldn't want to eat it, but it looks delicious. All right. Last video we'll have will be nylon.